This
what is the
conference will now
hydrograph.
be recorded.
We have already seen the hydrograph, unit hydrograph, right? And flood hydrograph. We have seen this. Just again, I will explain this, then it will be easy. Uh, See here, student, actually we have seen the hydrograph. Hydrograph, what this is, hydrograph is what actually, if suppose this is our catchment or area where the water is, rainfall occurred in this area, and this rainfall is coming through this river. This is our river, right? Right? And at the outlet, we are calculating, for example, this is the time after say at time 0, what was the discharge? So this is 0. Then after say after 1 hour, discharge came here to a 10 meter cube per second, right? Then after 2 hour, it came say 20 meter. Then after 3 hour, it came say 30 meter cube per second. Now this rainfall, why this rainfall is started, right? This rainfall, and this rainfall is occurred for say 2 hour. So after 2 hour, this is stopped. So then say after 4 hour, the discharge which is collected here, now it is reducing. Then after 5 hour, it is 10, and then after the 6 hour, it becomes almost 0, right? So then what we do, we take paper and we take on x-axis, and on y-axis we take the reading, right? On x-axis we take the time, on y-axis we take this q value, right? This q value in meter cube per second. So here we take this value. Suppose this is 0, then this is say 1 hour, then say 2 hour, this is a 3 hour, this is a 4 hour, this is a 5 hour, and this is a 6 hour, right? On y axis, we take the Q value. Q value is whatever says, suppose we have taken this as a, say this is 10, this is not 10, this is a 5, this is 10, this is 15, this is a 20, 25, and so this is 30, right? So here, just we plot the graph. Graph means on x-axis we take time, on y-axis we take the discharge. So suppose this is 10, so here 10, then we got say suppose 20, right? Then this is 30, and again this is 20, this is 10, and then finally it is 0. When we will when we will join this, we will get the graph, and this is called as hydrograph, right? Now up to here it was clear, right? Just I have repeated it. Is this okay? I have just repeated it. Yes or no? Mira, Nadia, Salim, Zaid, is this okay? This is we call it as a hydrograph, right? Now, now, if suppose now what we had discussed here. Suppose this is our graph. This is our graph, right? And here it is started somewhere here, right? So this is what, this is the base flow, right? And base flow plus, and this is what, this is hydrograph, direct runoff hydrograph, direct runoff hydrograph. And when we will add these two, this hydrograph will be called as this hydrograph, this total hydrograph will be called as the flood hydrograph, right? Flood hydrograph. Now, if suppose we are deducting this, we will not include this base flow, then this hydrograph will be like only this, right? It will start from 0. So we say this is direct runoff hydrograph. Now, what I told you, suppose in the catchment, if suppose this is our catchment, right? In the catchment, the rainfall occurred here is 1 centimeter only. And due to this 1 centimeter, what happened? This water will come in the river, right? This water will come in the river and it will collected at this point. And this may be collected again, say for 6 hours, say 0, then 1 hour, then after 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. This is time, and this discharge is calculated here. Suppose zero at zero time it was zero. At after 1 hour, say after 1 hour, it became say 10, then 20, then 30. Then after this is became 20, then this is 10, and this is 0. So again, we will get what type of graph? The same thing, same graph which we have just seen above. This graph, for example. So when this graph is occurring because of 1 centimeter rainfall, right? Is this okay? Well, see, my point is clear what I'm going to say. When we will draw the graph, and this graph will, when we will draw the graph, right? This graph will be same as like, but this graph is because of 1 centimeter rainfall depth, right? Rainfall depth, or 1 centimeter excess rainfall depth, right? So when in the catchment, the rainfall occurred here only 1 centimeter, only 1 centimeter rainfall occurred, and through this 1 centimeter rainfall, this hydrograph is drawn, right? So this is a Q, and this is the time in hour, right? So this graph will be called as the unit hydrograph. Is this clear? So there are the three terms. First is flood hydrograph, right? Second one is direct runoff hydrograph, and third one is unit hydrograph, right? So there are the three terms. So unit hydrograph is clear, direct runoff hydrograph is clear, flood hydrograph is clear. Within this, we consider the base flow, right? If base flow is not there and just only the hydrograph is drawn, but this graph may be for 2 centimeter rainfall, this may be for 3 centimeter rainfall, this may be for 4 centimeter rainfall, right? So then we will say the direct runoff hydrograph. But when this hydrograph is drawn because of only 1 centimeter rainfall, then this is called as unit hydrograph. Is this okay? Is this okay? This difference is clear? Now, after that, I will come to another my point. See, this is the same thing. This is what? So if you will see here, if you will see here, only you will see this 1 centimeter excess rainfall, 1 centimeter because of 1 centimeter excess rainfall. This hydrograph is drawn, right? So here you will see that the hydrograph that results from 1 inch or 1 centimeter of excess precipitation is spread uniformly in the space and time over the watershed for a given duration, right? What I told you, just because of 1 centimeter or 1 inch, just because of unit rainfall, we can say that unit may be 1 inch, that may be 1 centimeter, right? So then we say that this is the unit hydrograph. Now here you will see that, see, uh, only 1 centimeter rainfall occurred, and this discharge is calculated after every 6 hours. See, from 0 it was 0. Then after 6 hours there may be some discharge, right? Then after 12 hours there may be suppose this discharge, right? If I will here somewhere here. Then after say 18 hours it came here, right? Then after 24 hours there they just see after every 6 hours After every 6 hours, the discharge is estimated. See, this is our catchment, and at this point, water is collecting at this point. So after every 6 hours, that this Q is noted down, right? See, at zero time it was zero. Then after 6 hours it was something. Then after 12 hours it was something. Then 18 for 24. So it continues up to what time? Up to 66 hours, right? So here you will say that, see, this is what this will be called as 6 hour unit hydrograph, right? 6 hour and unit hydrograph. Is this clear? What my point is clear? Unit hydrograph and this graph is clear. Means the rainfall is only 1 centimeter, and because of 1 centimeter, this whole graph is prepared, right? And the reading is this this Q reading is taken after every 6 hours. That's why it is called as 6 hour unit hydrograph, right? For example, if suppose after every 4 hours this Q reading is calculated, or this Q reading is noted down, then we will say that this is 4 hour unit hydrograph. Is this clear what I'm saying? My point is clear to all of you? Means at every 6 hours this Q value is noted down. There, this may be say 4, this may be say 4, 8, then 12, 16, and then 20, then 24, then 30, 34, likewise. So if this reading is noted down at after every 4 hours, right? At every 4 hours, then I will say this is 4 hour unit hydrograph. Is this okay? My point is okay. Now, suppose if this reading is noted down after say 2 hours, and the rainfall occurred is only 1 centimeter, then what we will say that is 2 hour unit hydrograph, right? Power unit hydrograph. If suppose this reading is noted down after say 3 hours, every 3 hours, there's a 3, then 6, then 9, then 12, likewise. Then we will say that this is a 3 hour unit hydrograph. Is this okay? Now, once this unit hydrograph is clear, so the unit hydrograph of different durations are needed. For example, 1 hour unit hydrograph or 2 hour unit hydrograph, etc. What I told you, we can draw now for different hours unit hydrograph, right? So here there are the two methods available to generate the hydrograph for the different durations, right? So here there are the two methods. What are these methods? The first method is method of superposition, and the second one is the S-curve method. There are the two methods which are used for uh, preparing the hydrograph, unit hydrograph, right? Now, what are these methods? We will see here. See here. First method is superimposition method. Superimposition method means what? See, method is superimposition method or superposition. We can say superimposition method means what? For example, 3 hour unit hydrograph, or just we can say hydrograph is given. 3 hour unit hydrograph is given. 3 hour unit hydrograph is given, and it is said that prepare the 6 hour unit hydrograph unit hydrograph or prepare the 9 hour unit hydrograph, then we can use this superimposition method, right? What is this? What is the meaning of this? Say what I am saying, that say this time is given, for example, right? This time is given 0, then 3 hour, then 6 hour, then 9 hour, right? Then 12 hour, right? And this q is given at 0 time, the q was 0. This is in meter cube per second. And after 3 hour, the this q is measured as a say 10 meter cube per second. After 6 hour, it is measured as a 20 meter cube per second, and after 9 hour it is measured as a say 30, and then again it is 20, and likewise, right? Now this is what, this is 3 hour unit hydrograph. Means after 3 hours, after every 3 hours we are measuring the discharge, and the rainfall is 1 centimeter, but we have to prepare for the 6 hour. So for preparing the 6 hour means what? See, what is this meaning? This meaning is that on x-axis I will take time, and on y-axis I will take these ordinates, right? Ordinates means this 0, 10, 20, 30, 20, likewise, right? And on x-axis I am taking this time 0, then 3, then 6, then 9, then 12, and likewise. Suppose at after 3 hours, what was this one? This is 10 meter. Say this is 10, 20, 30, 40, likewise. So after 3 hours, this was the discharge was 10. Then after 6 hours, it was say 20. Then after again 9 hours, it was say 30, somewhere here, right? Then after 12 hours, it is say 20, somewhere here, right? So when we will draw this graph will be called as this graph will be called as 3 hour unit hydrograph, right? Now we have to prepare for the 6 hour unit hydrograph. 6 hour unit hydrograph means after 6 hours what happened. Then what we do, we prepare the 6 hour unit hydrograph by this superimposition method. So when we have to prepare the hydrograph from 3 hours, say 6 hours or 9 hours, it is not compulsory. 3 hours we can prepare for from 3 hour unit hydrograph. We can prepare for 8 hours, for say 7 hours also, right? But when we have to prepare the hydrograph from 6 hours to 3 hours, then we cannot use this method. We can use the S curve method. So here I will tell you. See here. See, this is what, this is the time is given. Just I will increase the size. If you will see, we have already told that when we represent this is what, this means, this is a d hour. D means this d may be any hour. So here it is 4, 8, 12, 16, means this is 4 hour. I will say this is 4 hour and unit hydrograph. My point is this okay what I'm saying? See, this hydrograph is what, this duration is 4 hour, 4 hour, right? And this depth excess rainfall is of 1 centimeter, right? So at 1 centimeter, because of 1 centimeter rainfall, and it is occurred here, here. First, you will see this hydrograph. This hydrograph is generated just what I discussed with you. They have taken the ordinate on x-axis and they have taken the ordinate on y-axis, and they have prepared this hydrograph like this, right? Now after, see what you will see again after 4 hour. So this is 4 hour, this is 4 hour, and again this is 4 hour, and rainfall is occurring only 1 centimeter depth. So here again they have started just by leaving these 4 hours. They have prepared one more hydrograph, this one. Then again after 4 hour, they generated this hydrograph. Now means what? See example what I want to say you that this hydrograph is first is drawn, that is A. This hydrograph is drawn, say this is B, and this hydrograph is drawn, and this peak is say C, right? But we have to generate, we have to superimpose, means we have to add the ordinates of A, B, and C. So what we will do? We will add this A plus B plus C, then we will get this hydrograph, this big one. When we will see this example, then it will be clear to you. Now I want to show one example. See here. Hello student, my voice is clear. What I'm telling you, is this okay? What I'm telling you, is this okay? This point is clear. Yes, Salim, Zayed, Nadia. See here. See, the table is given here. You can see this time is given, right? And now I will explain you. This is what. Suppose this is our catchment area, and this is the river, right? Rainfall occurred here, and due to this rainfall occurred here, and after say this rainfall is occurred, and after the rainfall, this discharge is collected at this point. Means a person is here, one person is here, and he is noting down after every 2 hours what is this Q value, right? So you will see that at 0 time the Q value is say 0, that is unit. Here you will see that mm, you will see that at 0 time it was 0. Then after 2 hour, this is became 10. 10 means what? 10 meter cube per second, right? Then after 4 hour, it is 30 meter cube per second. After 6 hour, it became 20 meter cube per second. And after the 8th hour, when a person came here, the discharge was 0, right? Discharge was 0. So here what is means what? At after every 2 hour, if after every 2 hour, this discharge is calculated here, right? Discharge is calculated here, and we got this reading 0, 10, 30, 20, 0. Now what I'm going to say here, we have to get the hydrograph of 4 hour from 2 hour. Means we have the reading only this one, we have the reading only this one. Then we have to prepare the 4 hour hydrograph, and from 2 hour hydrograph. Then what we will do here, what is the procedure here? See, once after, see, again you will see this lagged by 2 hour. What is it mean? Lagged by means, again we will draw the hydrograph just by leaving this 2 hour. This is 2 hour, is we will leave this 2 hour, and again the same ordinate 0, 10, 30, 20, 0 we will keep here. So add, and it will start from this 2. This will start from 0. So here we will keep the same ordinate just by lagging 2 hour, and it will be 0, 10, 30, 20, 0. And again we will draw the graph, the same graph we will draw here. This one will be, this blue will be this one, right? Now, once after 2 hour, so this is 2 hour unit hydrograph and this is 2 hour unit hydrograph. When we will add these two, we will get the 4 hour hydrograph, right? So we have to add just only these two. So 0 plus 0 plus nothing is here, so that will be 0. See here, we will add the column 2 and column 3. So here you will see that this is column 2 and this is column 3. So 0 plus 0, nothing, 0. Then 10 plus 0, it is 10. Then 30 plus 10, it will be 40. Then 20 plus 30, it will be 50. Then 0 plus 20, it will be 20. Then 0 plus nothing, it is 0. Now we will get this column, and this column is a fourth column. So this fourth column is the direct runoff hydrograph for 4 hour, because we have added this 2 hour hydrograph and again this 2 hour hydrograph. When we will add this 2 hour hydrograph, we will get the 4 hour hydrograph, that will be called as direct runoff hydrograph. Is this okay? Now for example, now but see here, one thing you should know that, see, if you will see this, no, see here, this is what direct runoff hydrograph, and this fourth column, right? But we require, actually we are, what we are doing, we are adding this blue one, we are adding this blue one, and this one, these two we have added, right? So we got this direct runoff hydrograph, but this is only direct runoff hydrograph, but we want the 4 hour hydrograph, only 4 hour hydrograph for 1 centimeter rainfall, for 1 centimeter rainfall. See, this rainfall is, this hydrograph is because of 1 centimeter rainfall, so here it is written 1 centimeter. Then again this column is because of again 1 centimeter rainfall. It means this 1 centimeter plus 1 centimeter, because of this 2 centimeter rainfall, we got this ordinate, but we got we require the 1 centimeter rainfall depth. Because of 1 centimeter rainfall depth, what is the 4 hour unit hydrograph? I think it is clear or not clear. Is this clear or not clear? I think it will be little confusion is there, because it is little is small complicated, but you should understand this. It is little complicated, but see, what I want to say to you, that Salim, clear? Nadia, is this clear? Zayed, is this clear? what I want to say that this ordinate, this ordinate is what? See, 0, this is time, our time, right? 0 time, then 2 hour, then 4 hour, then 6 hour, 8 hour, and then 10 hour. And this is my time, right? And after 0 hour, this q is what? This is what? This 0 time, 0, then 10, then 30, then 20, then again 0, right? This discharge is calculated at after every 2 hour. This is 2 hour, then again 2 hour, then 2 hour, then 2 hour, right? So this is what? This is 2 hour ordinate. 2 hour ordinate. 2 hour ordinate means at after every 2 hours the reading, this reading is taken, right? This reading is taken at the outlet of this catchment, at the outlet of this catchment, and after every 2 hours these readings are calculated. And once we calculated this reading, we draw the graph like this. Then after see, but this is 2 hour ordinate, and the rainfall is because only 1 centimeter. Because of 1 centimeter rainfall, this ordinate is observed at after every 2 hours. Then again, what I am saying you, the same 1 centimeter rainfall again occurred, right? In the same catchment. In the same catchment, after 2 hours, 1 centimeter rainfall again occurred. So that rainfall occurred after 2 hours. That's why you will see that this, that's why you will see that this is kept as a dash, and this 0 ordinate, this 10, then 30, then 20, then 0 is again kept here. But after 2 hour means this is 0, then say this is 2, then say this is 4, then 6, then 8, likewise. So after 2 hour, again if we will draw the same ordinate, it will come like this, right? Then again, when we will add these two hydrograph, when we will add these two hydrograph, we will get some new hydrograph. And how it will come? Something like this. So this hydrograph will be called as direct runoff hydrograph, but this direct runoff hydrograph is because of 2 centimeter rainfall. If we want unit hydrograph, then what we will do? If we will divide this ordinate by 2, then we will get the 1 centimeter, that is unit hydrograph. We will get the unit hydrograph for 4 hour ordinate. Is this okay? So that's why you will see that once this column 2 and column 3 is added, then it is divided by 2. Why this is divided by 2? Because of this hydrograph is because of 2 centimeter rainfall, but when we will divide it by 2, it will become 1 centimeter, and we will get the unit hydrograph for 4 hour duration, but rainfall will be only 1 centimeter. Is this okay? So you will see that when we will divide it 0 by 2, that is 0, then 10 divided by 2, it will become 5, then 40 divided by 2, it will become 20, 50 divided by 2, it will become 25, and 20 divided by 2, it will become 10. And we will draw this ordinate, and you will see that this red line, this red graph, hydrograph, this is our 4 hour unit hydrograph. This is 4 hour unit hydrograph. Is this okay? Is this okay? I hope it is clear to you. So this technique is called as the superimposition technique. So here the same thing is here. This is superimposition technique. So here you will see that now once it is clear, here one numerical is given. Numerical is just, see what numerical is saying, that given the ordinate of 4 hour unit hydrograph, what is it mean? What is it mean? It means that 1 centimeter rainfall is occurred. Rainfall occurred. This rainfall is 1 centimeter, right? And due to 1 centimeter rainfall, the discharge, this Q is calculated at F after every 4 hour interval. First it is 0, then 4, then 8, then 12, then 16, then 20, right? This Q is calculated at after 4 hour. That's why it is called as 4 hour unit hydrograph. Is this okay? First, is this clear? This basic definition is clear. What is the meaning of this 4 hour unit hydrograph? 4 hour unit hydrograph meaning is clear. 4 hour unit hydrograph meaning, now 4 hour unit hydrograph meaning is clear. Means 1 centimeter rainfall occurred, but this 1 centimeter rainfall is when it is when is noted down at the outlet of the catchment, then this is calculated at after every 4 hour, then 4, then 8, then 12, then 16, likewise. Now once it is clear, I will come to next point. So they have already given this data, right? After 0, 4 hour, 8 hour, 12, 16. These are the ordinates 0, 20, 80, 130, 150, 130, 90, likewise, right? Now what they are asking, we will see this. So unit hydrograph as below, derive the ordinate of 12-hour unit hydrograph for the same catchment. Means what? If suppose we have to calculate what would be the after 12 hour, then 12 hour, then say 24 hour, then 36 hour. If we will go to the outlet of the catchment, and we have only 4 hour unit hydrograph ordinate, but they are asking what would be the 12-hour unit hydrograph. You calculate this. So simply, if we know the 4 hour unit hydrograph, then plus again 4 hour unit hydrograph, right? Again plus 4 hour unit hydrographs. So we can get this 4 plus 4 plus 4. We can get for the 12-hour unit hydrograph. What would we, how we will draw like this? Is this okay? This question is as simple as, like, they are saying that at 4 hour we calculated the discharge was say 50 meter cube per second, right? Then they are saying that after 8 hour it was say 100 meter cube per second, right? Then after 12 hour they are saying that this is, for example, I'm telling you 150 meter cube per second, right? Now they are asking that they have given only the every 4 hour data. After 4 hour, what is this q value? And they are asking based on this 4 hour data value, please tell us the 12 hour, after 12 hour, what would be the q value at at every 12-hour interval, right? So once we will get for every 12-hour interval, we will draw the graph, right? Like this. Is this okay? Is this okay? Problem is clear to you? Problem is clear to you? No. So here what we will do, so first of all, we draw the table. For in first table we write the time. In the This is the second column. In the second column we will take this discharge Q, right? And after in the third column, I should not do like, right? Otherwise, see. So in the first column, they have taken the time 0, 4, 8, 12, 16, 20, right? If you will see here, 0, 4, 12, 8, 12, 16, 20, 24, 28, 32, 36, 40 up to 58, because it is given in the question, right? Here it is given up to 44. Okay, we can do this. We can do this at up to when this column will be end. So here see, at 0 interval the discharge was 0. Then after 4 hours the discharge is how much? Here it is given at 0, 0. Then after 4 hours the discharge is 20. Then after 8 hours it is 80. Likewise, the same thing is filled here. 0, then 20, then 80, up to last one, right here. Now see what we want the hydrograph for 12 hours. So it means the same ordinate we will draw it by after lagging of 4 hours. So this we will start, this is our 4, this is our 4, right? So here you will see that exactly at 4 we will write this same ordinate from 4. So first in the third column we leave this blank as it is, and the same ordinates we will write here 0, 20, 80, 130, right? 150, 130, 90, up to we will write up to when it does not end, right? So it will end here, it will end up to here. Then again, see again, this rainfall ordinate we we will write it lag by 8 hours. So this is 8 hours, and this same ordinate we will write from here, but this will start after the 8. Here you will see this is starting after the 8 hour, right? So you will see that this ordinate is started after this 2. We will blank this, we will leave it as a dash, and then we will write the same ordinate, this ordinate we will write the same ordinate here. Then it will be 0, 20, 80, 130. Now so this has become the 4-hour ordinate, this is also our 4-hour ordinate, right? And this is also our 4-hour ordinate. So what we will do, this 4-hour ordinate plus this 4-hour ordinate plus this 4-hour ordinate, we will add these all these ordinates. So what we will get, see 0 plus dash is 0. Then 20 plus 0 plus dash, it will be 20. Then 80 plus 20 plus 0, it will be 100, right? Then now see here, then 130 plus 80 plus 220, it will be 230. So here it will be 230. Then 150 plus 130 plus 80, we will get 360. Likewise, we will add all these ordinates up to here. When it will end, so it will end up, yeah, here after, right? Now we have got this is 12 hour 12-hour ordinate, but this is what, this is because of 3 centimeter rainfall. Is this okay? What my point is, because this is because of 1 centimeter, again this is because of 1 centimeter, and this ordinate is again because of 1 centimeter. So means this ordinate is because of 3 centimeter rainfall. 3 centimeter rainfall. Is this okay? My point is clear what I'm going to say. This ordinate is because of 3 centimeter rainfall. This ordinate is because of 3 centimeter rainfall. But we want to convert this into unit hydrograph. We want to convert it into unit hydrograph. That's why we have to divide it. This ordinate we have to divide it by 3. So what we will do, when we will divide this ordinate by 3, then we will get the 12-hour unit hydrograph. Is this okay? So you will see that this 0 is divided by 3, we will get 0. So here you will see this 0 divided by 3, it will 0. This 20 divided by 3, you will get 6.7. When 100 will be divided by 3, you will get 33.3. Then 230 divided by 3, we will get 76.7. Then 360 divided by 3, we will get 120. Then likewise, we will divide it. Now, once we will get this ordinate, we will take the graph paper. On x-axis, we will take the time, and on y-axis, we will take this ordinate, right? So here you will see that, uh, just I will increase the size. See here. So when you will see this, see, we will take the time on x-axis as a 0, 4 hour, 8 hour, 12 hour, 16 hour, 20, then 24, up to we will go when we will go up to this ordinate does not end. So we will go, so at 0 it is 0, then at 4 hour it is say 6.7. So here it will write 6.67. Then at after 8 hour this is 33.3. Then after 12 hour it is say 76 point something. So here it will come 76 point something. And likewise, we will draw this point on the graph, and we will draw this graph. So this graph will be what? This graph will be 12-hour unit hydrograph. Unit hydrograph. Is this okay or not? If it is not clear, again I will tell you this problem. Don't worry about if you have any doubt, because this is very important, right? Is this okay? All of you, is this okay? See, what we are going to do, this is numerical, but what is exactly in the field, you should understand this. What we are going to do in the field, you should understand this. See, in the field, what is happening here, this is our catchment, right? And in the catchment, rainfall occurred, and this rainfall is what? This rainfall depth is 1 centimeter only. And here at this outlet, this discharge Q is noted down at after every 4 hour. After every 4 hour, this Q is noted. So when we will see this time and Q, when time was 0, this discharge is also 0, right? When time was say 4 hour, this discharge is having some value. Then when it was say after 4 hour, this discharge was having some value. So up to, we went up to say whatever it is, 44 hour or whatever it is. Once we got this value, what we do here, on x-axis and on y-axis we take time, say 0, 4, 8, 12, up to say 52 or 44 hours, whatever it is. And we draw these points, right? We draw these points, and we draw the graph. See, this graph is for our unit hydrograph. Why we are saying unit hydrograph? Because of this hydrograph is only because of 1 centimeter rainfall. Now, The question is asked. The question is asking to us. The question they are asking that based on this data, you draw the hydrograph for 12 hours. So 0, then 12, likewise. Means after see at 0 time the discharge is 0, right? Then after say 12 hour, what is this Q value? After 12 hour, what is this Q value? And after say 24 hour, for example, I'm telling you, they are asking the 12-hour unit hydrograph. They are asking 12-hour unit hydrograph. So what we do, we are just simply adding all these ordinates. Say first 4-hour unit hydrograph ordinate we taken on one column, then again just by leaving this dash means another rainfall is starting somewhere here after 4 hours. We will draw another graph. Then after say again 4 hours, we will draw another graph, right? So we have some ordinates, these ordinates, we have some ordinates here also. So once we will add these whole ordinates, we will draw one graph, but this graph will be for 3 centimeter rainfall. And if we want this for 1 centimeter, we divide it by 3 centimeter, then it will be 1 centimeter. So here we will get some ordinates, and that graph will be drawn. Then that will be called as the 12-hour unit hydrograph. Is this okay or not? If it is not clear, again I will tell you, because it is very, very important. Means for your life, you should know what is hydrograph, what is unit hydrograph, and how you will draw from 4-hour unit hydrograph to 6-hour, from 4-hour to 12-hour, likewise. Right? So here I stop, and I will record some more numericals so that you should understand this, and then you will be able to solve this. And the next week, not this week, we will have a quiz in the next week. Is this okay? You want to speak something, you can tell me. If you want something, you want to tell something, you can tell me. You have any doubt, anything, you can ask.